Hello friends, in this video I am going to discuss about impulse response of a system, okay, by MATLAB. Okay, now let us try to understand first what is impulse response of a system. So the objective is basically, see here I have just given one simple systems and signals and system block diagram, that is here input is x of t, which in discrete domain can be represented as x of n, and the system response is h, and you are getting output as y of t, or if you consider discrete domain then that is y of n. Okay, so basically what is impulse response? If you provide x of, that is sorry, if you provide input as delta function, whatever output you are getting in the output section, that is basically impulse response. That is what I have written here. A system's impulse response, often denoted or annotated as h of t for continuous time system or h of n for discrete time system, is defined as the output signal that results when an impulse applied to the system input. Okay, this is very important. That means whenever you are providing input as delta function, whatever output you are getting, that is impulse response. And two response are very important to understand the property of a system. One is impulse response, another one is frequency response. Frequency response I have already discussed in my previous videos. You can check the playlist link I will give in the description, the DSP playlist link. So anyway, and now in this video we are going to deal with impulse response. So first we should understand why is it so important, why the impulse response. With the help of impulse response we can have some idea about the output, how we can understand. Let us try to understand. So why this is useful? For discrete time system, you can write any signal x of n as sum of scaled and time shifted delta function. Forget about the words, you already know this expression, right? In basic DSP or signals and systems already you have studied. There is x of n is equal to summation over k equal to 0 to infinity x of k delta of n minus k, right? It is, suppose I am better to give an example. Suppose x of n is 1, 2 and 3, and at n equal to 0 the value is the amplitude is 1. Then how will you represent in terms of delta function? Correct, 1 into delta n plus 2 into delta of n minus 1 plus 3 into delta of n minus 2, because this 2 is corresponding to n equal to 1, right? Sorry, n equal to 1. This 3 amplitude corresponds to n equal to 2, and this 1 amplitude corresponds to n equal to 0, because the arrow initially it was given below 1, right? These notations you know from the basic signals and system concept. Basically any discrete time sequence can be represented in terms of scaled and time shifted delta function, right? Now see what convolution theorem says, that if a system is linear time invariant system, then only first this is applicable. This is very important point to understand. Convolution theorem is only applicable for LTI system, not other systems. Okay, so like for time variant system it is not applicable. So try to understand. Suppose this is h of n minus k is nothing but time shift of the system's impulse response, right? Here I have written that where h of n is system's impulse response. So suppose you know h of n, and suppose you know x of n, that is the input which you are going to provide in the system, you know that, and the system's impulse response you know. Then at any time you can have an idea what is going to be the output, because from this expression we can get the output, because we know that output is basically convolution of the system's impulse response and the input which I am going to provide, and we can get by this formula y of n is equal to summation over k equal to 0 to infinity x of k h of n minus k. Okay, so here comes the importance of the impulse response of a system. If you know the impulse response of a system, then you can determine h of n minus k, x of k, that input which you are going to provide, that you can determine, because you are only going to provide the input, right? So you know input, you know system's impulse response, convolve them, you will get the output which is going to be the y of n. Okay, in terms of discrete domain, if you take continuous domain, then that will be y of t. Okay, so this is the importance of the impulse response of a system. That's what I have written here. The impulse response is useful because it allows us to calculate the output of LTI system for any input signal. The output is simply the input signal convolved with the impulse response of this impulse response function, and obviously this is again going to be applicable for LTI system, because you should always keep in mind whenever you're dealing with LTI system, then only convolution theorem is applicable. Okay, so this is what importance or objective of our calculation of impulse response. Now how to find that? See, in examination, this type of questions will be given to you, and this difference equation in terms of input and output will be given to you. You have to determine the system's impulse response. Okay, so what is the question? Let us try to understand. Y of n plus 0.71 y of n minus 1 minus 0.46 y of n minus 2 minus 0.62 y of n minus 3 equal to 0.9 x of n minus 0.45 x of n minus 1 plus 0.35 x of n minus 2 plus 0.002 x of n minus 3. Now first step is just calculate h of z, that is just calculate the z transformation of the your system. Okay, how to calculate? Very simple. Take the whole difference equation in the z domain, then you just calculate y of z by x of z. Okay, calculate y of z by x of z. So if you calculate, so in the numerator here it will be y of z, and in the denominator it will be x of z, right? Now just first try to calculate the z transformation of this given expression. So it will be y of z plus 0.71 y of z into z to the power minus 1 minus 0.46 y of z into z to the power minus 2 minus 0.62 y of z into z to the power minus 3 equal to 0.9 x of z minus 0.45 x of z into z to the power minus 1 minus 0.35 x of z into z to the power minus 2 plus 0.002 into x of z into z to the power minus 3. Okay, now you just calculate y of z by x of z. Easily you can understand that the x of z coefficients will be in the numerator and the y of z's coefficients will be in denominator in the transfer function h of z. So basically we can represent like the numerator and denominator by one array, where numerator will be 0.9, then minus 0.45, then 0.35, then 0.002. Okay, and denominator will be 1, 0.71 minus 0.46 minus 0.62. Just write the coefficients. Okay, now see, this we can get from this expression easily. Now in the examination, how they can twist the question so that student do mistake, what they will do after y of n, instead of just they will that is just they will remove this term y of n minus 1, and after y of n they will directly give y of n minus 2 term. So here comes the twist. Okay, so you should write in a order. See here, n, then n minus 1, n minus 2, n minus 3. That is proper, in proper order it is going, so that we can write the coefficients in order. But suppose y of n minus term is not given, that means you should, in that time you should understand like this: 0 into y of n minus 1. That is, in the y of n minus 1 term you should replace 0. That is here in the 0. Y of n minus term is 0.71, right? So instead of 0.71 you should write 0. Okay, so this is how the question may be twisted. So anyway, here you can understand easily how I have defined numerator and denominator. Now let us directly go to MATLAB and try to calculate the impulse response of the system for which the difference equation is given. So see, from here itself I am copying the numerator and denominator, and I will paste in the MATLAB. So basically first step is quite easy. Just write the numerator and denominator coefficients after taking the z transformation of the given difference equation, calculate h of z and write down the numerator and denominator in order. Okay, first coefficient of z to the power 0, then next coefficient z to the power 1 or z to the power minus 1, then next one z to the power 2 or z to the power minus 2. That is, should be order maintained. Okay, now to calculate the impulse response, the inbuilt MATLAB code is impz num comma den. Okay, so this will calculate the impulse response. Now stem y. Okay, by this you can get the plot of the impulse response. Now you may think we often write n comma y, like plot x comma y. But here by the same y itself it will work. Just let us check. MATLAB will automatically take the input samples, that is time sample values, and see this type of impulse response we are getting. Okay. Now, but this is not properly satisfying us, right? Because stem y, is this a proper manner? What we generally write, stem n comma y, n, that is time sample range should be mentioned, right? So for that, what you can do, let me show you once again. See, the impulse response, it is calculating for a particular time samples. Like see here, to this time sample, that is after 71, 2, 3, 4, 5, that is up to 75 samples. First 75 samples it is calculating, because after that all are zero, so that it is not, MATLAB is not going to calculate further values. So what you will do in examination, to understand easily, define the sample range for which you want to calculate the impulse response. That's what. So let me give 45. Whatever you wish you can give. I am giving 45 because there is no reason for giving 45, just to show you the plot. And how the code will change. Impuse num comma 10 comma capital N you write. Okay. Stem y. Now see, define n range. N will be equal to 0 to n minus 1, capital N minus 1, right? Because you know the first index position of array in MATLAB is 0, then what, sorry, 1, sorry, first index position of an array in MATLAB is 1. Now if you start from 0, then it will go up to n minus 1. If you start from 1, then it will go to n. Okay, I hope you know this already. I have discussed several times in my previous videos. So stem n comma y. Now control A, evaluate selection. Okay, see, this is what the response is going to be for n equal to 45 samples. Okay, now see, I told you that impulse response basically gives the output, basically nothing but this system output when we are providing unit impulse signal. So better to use that instead of using impz command, that is instead of using inbuilt command, we will derive the code from the mother equation itself. So what you will do, just remove this line. Okay, and n is defined, fine. Now x equal to, define the direct delta or simple delta function. You know how to write the delta function code in MATLAB, that is n equal to 0. Okay, because this condition will be 1 when n equal to 0. For all other case it is going to be 0. Okay, so x is delta function is defined. Now numerator denominator of the system is defined. So what we will do, we have to take the output, that is system response output when input is impulse, and we know the system numerator and denominator coefficients of the Z transformation. Then how to calculate, you know, that is filtered. Okay, to get the output we use filter command. So filter num comma 10 comma num comma 10 comma unit impulse, that is x. Okay, so let us try to check whether we are getting the result or not. Evaluate selection. See, same result we are getting. Again I will compute. See, so in this way, so this is basically the impulse response of the system, where the given difference equation was this one. Okay, this was the given difference equation. From there we are able to calculate the system response, impulse response. And how we have calculated it, if you don't want to remember the inbuilt commands, then you can follow this method. Instead of using impz command, what you can do, you just pass the delta function through the system. Whatever output you are going to get, that is basically system's impulse response. Okay, so this is what the code to get the plot of the impulse response of a system if the given difference equation is there. So I will post the same code in the description of this video. You can check there. Okay, thank you for watching, and for more videos related to electronics and communication engineering, please subscribe my channel and don't forget to press the bell icon. And if this video is helpful to you for boosting your concepts in MATLAB, please like, share and comment. Thank you.